Hello everyone, my name is Nat and I am a scientist and a researcher at Lipotech. Lipotech is a company that is actually based in Spain, so I'm no longer in the UK, but when I was a student at the University of Warwick, I made so many good friends there that I still do a lot of work with people at the University of Warwick. So this is a picture of me you can see now on the slide, but I know a lot of you are still in school, so I thought I'd show you how I looked when I was in school. This is a picture of me. I was maybe 10 or 12 years old here. So there you go. I almost didn't change at all from there. So at this point, when I was in school, I was actually I'm Portuguese, so I was actually doing my school in Portugal, in this town here. It's called Tomar. It's in the middle of Portugal. It's a very small, but as you can see, it's a pretty town. And I attended school in this school here. I suppose it looks like just any other school. And for the last 3 years at school, I had to choose between science, humanities, or sports, and I chose the sciences. And there was never really a point in time where I can say that I chose science because I really knew science was for me. It was more of a case that the science subjects always were more interesting to me. So I wasn't so interested in history or geography, but I really wanted to know how plants worked and how our bodies worked and things like that. So the science subjects were always more interesting to me. So that's why I chose science. And again, for the last 3 years of school, I was doing things like chemistry, physics, biology, geology, and maths. So yeah, once I finished school in Portugal, I came to the University of Leicester in the UK. And I started my university degree, which is called an MChem. An MChem just means, well, it's 4 years. It's a university degree that lasts for 4 years. And in my case, I had a year in industry, which means that the first 2 years I spent at the university and I had my lectures and my lab work. I think the labs were in this, I think this floor here is where the labs were. So for year 1 and 2, I spent all of my time at uni. But then for year 3, I actually spent it somewhere else because I went to do a year in industry, so a work experience year. And then I came back for year 4 to do my year of what's called a master's, which just means you are studying something a bit more specific. You're going more in depth in a part of research, a part of science that interests you the most. So those were my 4 years of my first university degree, but I just wanted to show you where I spent my year 3, so that work experience year. I was actually here at the Rutherford Appleton Laboratories, and this is in Didcot, close to Oxford. And all of these buildings you can see here, there's lots of really great and interesting science going on. But I was based, I think it was this tiny building here, and this is where I started working with lasers. So I was doing a degree in chemistry, I was always a chemist, but this was my lab. So this is probably not what you would think a chemistry lab looks like, but if you are a laser scientist, a laser chemist, this is more likely what the lab looks like. So forest of mirrors and metal and things like that. So no glassware, no lab coats. It's a bit different. But so this work experience year, it's really the year where I fell in love with lasers and I knew I wanted to do research with lasers. So after I finished my 4 years at the University of Leicester, I went to the University of Warwick to do a PhD. So I wanted to study a bit more. I wanted to do a bit more work with lasers. So again, this is how my lab looked like. You can see another forest of mirrors and metal and things like that. And I was using lasers to study sunscreens. And after 4 years at the University of Warwick, I then got my PhD, and here's a picture of me at graduation with my funny hat. And then after my PhD, I moved to Lipotech, where I am now. This is a company that works with cosmetics. And so, like I was saying, in my PhD, I was using lasers to study sunscreens. And now I am using what I learned with my lasers. I'm using that to actually look into the sunscreens, the products, the creams that we make. And you can see the labs look very different. The labs in a cosmetics lab actually sometimes looks a little bit like a kitchen, as you can see. This is actually a cream, a lotion that you'd put on your skin, because you have to mix a lot of things together. You actually you use a mixer very much like you would use to make the dough for your cake. So there you go. The lab is very different. So I changed a little bit from my laser to now making cosmetics, but I'm still studying sunscreens. So what does research life look like? I spend a lot of time in the lab, and I'm very happy to be, you know, I get the chance to work with lots of different products, lots of different colors and textures, and I get to mix and match a few things. So I spend a lot of time in the lab, which I enjoy. There's also a little bit of write-up, so I do spend some time here in my office as well. But I also enjoy, you know, going to the beach. Lipotech is actually only maybe 10-15 minutes from the beach, so I can leave work and go to the beach for a walk, which I really enjoy. But now, just to finish, I wanted to tell you a bit more about the actual science that I do about these sunscreens and what I'm doing now at Lipotech. So I'm trying to understand what sunscreens do with the light, right? So you know that if you go out in the sun, you should apply sunscreen, because the sunscreen protects your skin from the light that comes from the sun. But my question is, but why do they protect you, and what are they doing with the light so that they are able to protect you? What's going on? So if you take a bottle of sunscreen that you have in the house, you will probably see an SPF. So we say it's SPF 30 or 50. It'll be written in the bottle. And that protects you against UVB, which are the more energetic rays from the sun. But nowadays, you also have this symbol here. You can go and look at your sunscreen bottles to see if you find it. And this shows that your sunscreen also has protection against UVA, which is just a different type of light. But they are both harmful, so you need protection for both. So the thing is that the things that you put in your sunscreen to protect, the molecules that you put inside to protect your skin, none of them can protect both against UVA and UVB. They can't do both. So what ends up happening is that your sunscreen has a mixture of molecules that protect you against either UVA or UVB. So if you look at the back of a sunscreen bottle, this is a sunscreen bottle I have at home, and because I've been working a lot with these things, now I know which one of these ingredients are the ones that are actually protecting us. And so some of these are homosalate, octocrylene, and other things with these long names. But as you can see, they are a mixture of molecules that give us protection. And the thing with combining sunscreens is that those combinations aren't always good. So for example, one of those ingredients is avobenzone, is this molecule that I'm showing here. And when you combine that with another sunscreen, which is octocrylene, that combination is good. They are stable, which means that you apply the sunscreen that has these two things, you go out in the sun, and it protects you for longer. It manages to protect you for longer. The problem is if you try to use, again, avobenzone, and you put it together with a different sunscreen, octinoxate in this case, it's not so good, which means that your cream doesn't protect you for as long. The sunscreen is not stable. It doesn't like this combination of sunscreens, and the protection goes away pretty quickly. So my question is, but why does this happen? Why is combining some sunscreens good? Why are others bad? And how can we make sure that every time we combine sunscreens on the same formula, that it's a good combination? So this is what I'm trying to look for. And the way I do that, trying to figure out which combinations are good and why they're different, I use this machine, which is an SPF calculator. And so I use these there's these like plastic squares where I put a little bit of sunscreen. I apply the sunscreen to the plate, so I rub it on the plate, and then I put this plate on the machine, and I take it's like I was taking a picture of how much protection the sunscreen gives you when you apply it. And then I put this plate under a solar simulator, so I don't put it in actual sun, but it's like a very strong lamp that simulates the sun. And then I take another picture of it and I try to see how that protection has changed, so I can see which combinations protect as much before and after the sun, or which ones are not very good after they've been in the sun, and so I can test which combinations are good, and then I try to understand why the difference. And so yeah, this is it from me. I hope you have enjoyed that, and I hope you enjoy the rest of the series. Thanks very much for listening. Goodbye.